It is understandable that one would be upset about the situation. You paid for a specific product and received something different, which is a major inconvenience. When faced with an incorrectly packaged electrical panel, there are several steps to take. Firstly, gather evidence. Take photos of the panel, the box, and any labels that indicate the incorrect contents. If possible, document the conversation or incident when the panel was purchased. Secondly, contact the store where the purchase was made. Explain the situation clearly and provide the evidence. It is important to become an assertive, but also polite and respectful. Thirdly, request a replacement panel with the correct 30-40 circuit bus assembly. You can also ask for compensation for your time and inconvenience, such as free delivery or a store credit. If returning the panel is a challenge due to traffic, inquire if the store offers alternative return arrangements. Consider contacting the store's customer service department to explore options for remote returns or pickups. Here are additional tips to keep in mind. If the store refuses to cooperate, contact a consumer protection agency or the Better Business Bureau. Document all communication and interactions with the store. Stay patient and persistent, as resolving this issue may take some time. Remember, it is important to approach the situation professionally and respectfully. The goal is to get the correct panel as soon as possible with minimal hassle. Now let's delve deeper into the technical aspects of electrical panels and why receiving the correct one is crucial. An electrical panel, also known as a breaker box or load center, is the heart of an electrical system. It distributes electricity throughout the building, providing circuit breakers to protect each circuit from overloads and short circuits. The panel's bus assembly is a critical component, as it provides the conductive pathways for electricity to flow from the main power source to the individual circuits. The number of circuits a panel can accommodate is determined by the number of spaces available for circuit breakers. A 20-40 circuit panel typically has 20 spaces for standard single-pole breakers or 40 spaces if tandem breakers are used. Tandem breakers, also known as duplex or half-size breakers, allow two circuits to be installed in a single breaker space. A 30-40 circuit panel, on the other hand, has either 30 spaces for standard breakers or a combination of standard and tandem breakers to reach a maximum of 40 circuits. Using the wrong panel can lead to several problems. Firstly, it can limit the number of circuits available, potentially requiring the installation of additional panels in the future. Secondly, it can create confusion and safety hazards if the panel is not properly labeled. Thirdly, it can violate electrical codes and regulations if the panel is not sized appropriately for the electrical load. When selecting an electrical panel, it is essential to consider the current and future electrical needs of the building. The panel should have sufficient capacity to handle all the circuits required, with some spare capacity for future expansion. The panel should also be rated for the appropriate voltage and amperage. In residential applications, the standard voltage is typically 120 volts or 240 volts, while the amperage rating depends on the size of the service entrance. The National Electrical Code, or NEC, provides detailed guidelines for selecting and installing electrical panels. Article 220.12 of the NEC covers the requirements for calculating branch circuit, feeder, and service loads. Article 312 of the NEC covers the requirements for installing cabinets, cutout boxes, and meter socket enclosures. It is crucial to consult the NEC and local electrical codes to ensure that the electrical panel is installed safely and correctly. When inspecting an electrical panel, there are several things to look for. Firstly, check the panel's label to verify that it is rated for the appropriate voltage and amperage. Secondly, check the panel's wiring to ensure that all connections are tight and secure. Thirdly, check the circuit breakers to ensure that they are properly sized for the circuits they protect. The NEC provides guidelines for overcurrent protection in Article 240.4. It is important to replace any damaged or defective circuit breakers immediately. Fourthly, check the panel's grounding system to ensure that it is properly connected to the grounding electrode system. The NEC provides guidelines for grounding and bonding in Article 250. It is important to maintain the electrical panel in good condition to ensure its safe and reliable operation. Regularly inspect the panel for any signs of damage or deterioration. Keep the panel clean and free of dust and debris. Replace any worn or damaged components promptly. If you are not comfortable working with electricity, hire a qualified electrician to inspect and maintain the electrical panel. Working with electricity can be dangerous, and it is essential to take all necessary precautions to avoid electric shock or fire. Always turn off the power to the circuit before working on any electrical components. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Follow all applicable electrical codes and regulations. If you are unsure about any aspect of electrical work, consult a qualified electrician. In summary, receiving the correct electrical panel is crucial for the safe and reliable operation of the electrical system. If you receive an incorrectly packaged panel, take the necessary steps to resolve the issue with the store. When selecting and installing an electrical panel, consider the current and future electrical needs of the building and consult the NEC and local electrical codes. Regularly inspect and maintain the electrical panel to ensure its safe and reliable operation. By following these guidelines, you can help ensure that your electrical system is safe, efficient, and code compliant. Now let us discuss the components of an electrical panel more thoroughly. 1. The enclosure is the metal box that houses all the components of the electrical panel. It protects the internal components from physical damage and environmental factors. 2. The main breaker is the largest circuit breaker in the panel. It controls the power supply to the entire panel. 3. The bus bars are the conductive strips that distribute power from the main breaker to the individual circuit breakers. 4. The circuit breakers are the protective devices that interrupt the flow of electricity in the event of an overload or short circuit. 5. The ground bus is the conductive strip that connects all the ground wires in the panel. 6. The neutral bus is the conductive strip that connects all the neutral wires in the panel. 7. The wiring is the insulated conductors that carry electricity throughout the panel. 8. The labeling is the system of marking each circuit breaker with the corresponding circuit it protects. 9. The knockout is the removable portion of the enclosure that allows wires to enter and exit the panel. 10. The dead front is the removable cover that protects the user from contact with live electrical parts. Each of these components plays a vital role in the operation of the electrical panel. It is essential to understand how these components work together to ensure the safe and reliable distribution of electricity. Furthermore, consider the different types of circuit breakers commonly found in electrical panels. Firstly, standard circuit breakers are single-pole breakers that protect a single circuit. Secondly, double-pole circuit breakers protect two circuits simultaneously. They are commonly used for 240 volts appliances such as water heaters and air conditioners. Thirdly, ground fault circuit interrupters, or GFCIs, protect against ground faults. They are commonly used in bathrooms, kitchens, and outdoor areas where there is a risk of electric shock. Fourthly, arc fault circuit interrupters, or SIs, protect against arc faults. They are commonly used in bedrooms and other areas where there is a risk of fire. Fifthly, combination of SI/GFCI breakers provide both arc fault and ground fault protection. They are becoming increasingly common in new construction. Selecting the appropriate type of circuit breaker for each circuit is crucial for safety and code compliance. The NEC provides detailed guidelines for overcurrent protection, including the selection of appropriate circuit breakers. Now let's delve into the importance of proper labeling. Proper labeling of the electrical panel is essential for safety and convenience. It allows you to quickly identify the circuit that controls a particular outlet or appliance. It also helps to prevent accidental disconnection of the wrong circuit. When labeling the electrical panel, use a permanent marker or label maker to clearly identify each circuit breaker. Be sure to include the location of the outlets and appliances that are controlled by each circuit. Update the labeling whenever you make changes to the electrical system. Consider creating a circuit directory that lists all the circuits in the panel along with their corresponding locations and appliances. This directory can be kept near the panel for easy reference. Proper labeling is not only a good practice but also a requirement of the NEC. Article 110.22 of the NEC requires that all electrical equipment be clearly and dubly labeled. In addition to labeling the circuit breakers, it is also important to label the panel itself with the voltage and amperage rating. This information is crucial for ensuring that the panel is not overloaded. Finally, let's discuss some common electrical panel problems and how to troubleshoot them. Firstly, trip circuit breakers are one of the most common problems. If a circuit breaker trips, reset it by turning it off and then back on. If the breaker trips again immediately, there is likely a problem with the circuit. Secondly, loose connections can cause a variety of problems, including flickering lights, overheating, and even fire. Check all the connections in the panel to ensure that they are tight and secure. Thirdly, corrosion can damage the components of the electrical panel and reduce its lifespan. Clean any corrosion with a wire brush and apply a corrosion inhibitor. Fourthly, overloaded circuits can cause circuit breakers to trip frequently. Reduce the load in the circuit by unplugging some appliances or moving them to a different circuit. Fifthly, ground faults can be dangerous and can cause electric shock. If you suspect a ground fault, contact a qualified electrician immediately. Troubleshooting electrical panel problems can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to diagnose and repair the problem. Always turn off the power to the panel before working on any electrical components. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow all applicable electrical codes and regulations. By understanding the components of the electrical panel, the different types of circuit breakers, the importance of proper labeling, and common electrical panel problems, you can help ensure the safe and reliable operation of your electrical system. Remember to always consult with a qualified electrician if you have any questions or concerns about electrical work.